Okay, we continue today the review. Do you see that I sent the test, right? The written test in this email. Do you see,
Yes.
right? Uh-huh. Remember, this is
Yes.
due. This test is due this Thursday, so April 14th. And it's also due online, both, right? It's this Thursday. It's clear, this idea?
Yes.
Yes.
And remember, we have another test. Unfortunately, we have 5 tests. Remember, this test, this subject is long. Because actually, you take one subject que es 2 subject, es called algebra plus pre-calculus. So now, the only thing you should do is take in trigonometric and you are ready to take calculus. Okay? Okay, guys, entonces you are ready to pay attention or no? Or not yet?
Yes.
Ready.
Oh, ready. Okay, now we are doing the matrix part. Please pay attention, it's a little bit complicated. Okay, we are doing the question 21 is perform the row operations, the famous row operation on the augmented matrix. Augmented matrix is given and you perform 3 row operations. Okay, entonces the interpretation this. You have the original matrix. Now, you perform sequentially, one by one, so the order is important. This row operation. What means that? What is the meaning of this equation? Is you have a factor, que es -2. Multiply one by one each element in the row 1. This is row 1. This is row 2. And this is row 3. And no important the column in the matrix, no. In the determinant, yes, but in the matrix, no. Multiply by the corresponding element in the row 1 plus you adding the corresponding element in the row 2, and this new number you store or you put inside in the new matrix after the transformation. No? So let me try to do at least one in detail. For example, -2 is common. I copy -2, -2, -2, -2 4 times. Why 4 times? Because we have 4 columns, no? Column 1, column 2, column 3, column 4. So you multiply by the corresponding, for example, the first element in the row 1 is 1. Plus the corresponding is 2. And the answer is 0 because -2, so 1 times -2 is -2, and -2 plus 2 is 0. Okay, so you copy, if you want, copy any element in the row 1, que es -3, es -5, y es +2. And you adding plus the corresponding in the row 2, que es 182, -5 now, 2 and 5. Ok, entonces +6 plus -5 is 1. This is 10 plus 2 is 12. And this is -4 plus 5 is 1. And you replace that new number in the row, in the new row 2. So after this transformation, my matrix now is easy because you copy, for example, the row 1 participate in the game, however, it doesn't change. The only row that change is the row 2, que now is 0, 1, 12, and 1. And the row 3, no, do not participate in the game. This idea is clear or confusing? Clear or confusing?
Yes.
Answer me. Yes, clear, right?
Yes.
Okay. So, unfortunately, you need to do this by hand. It's not possible in the software. Okay, now let's do in the next row operation. Okay, the next row operation is -3 times row 1 plus row 3 equal capital. So the notation is, let me try to explain. Little r indicate the old row, and the new capital is the new que you compute, okay? And you're working sequentially. So now this transformation you apply on the next matrix. Therefore, this original, you forgot that. It's sequentially. You apply on this matrix. Entonces you copy -3, -3, and multiply by row 1, que is exactly the same number, doesn't change. 1, -3, -5, and 2. Plus the corresponding value in the row 3, que in that case is 3, -5, +4, and +6. Okay, and the answer is 0. This is 9, +9, -5, 4. And this is 15. +4 is 19. And this is 6. And -6 is 0, no? It's 0 because it's -6 plus 6 is 0. Okay, so my new matrix after the second transformation is, look, the row 1 and the row 2 stay the same. And the only row that changed, row 3, no? Okay, now it's 0, 4, 19, and 0. Okay. Everyone follow me, no?
Yes.
Okay. Let's do in the last one. The last one is 5 times row 2 plus row 3 equal row 3. So in this case, the factor involved in this operation is 5. You copy 5 4 times, multiplied by the corresponding element in the row 2, que is 0, 1, 12, and 1, no? And adding by the corresponding element in the row 3, que is 0, 4, 19, and 0. Okay, entonces the answer is, and this answer is 0, is 0, is 0, is 0, is 0, is 0, is 9, because 5 plus 4 is 9. And this is 60, it's 12 times 5, 60 plus 19 is 79. And this is 5. Okay, so my last, okay, by the way, is the last, no? Is 1, -3, and -5, 2. So the row 1 and the row 2 stay the same. Now change the row 3, que is 0, 9, 79, and 5. Okay? And this is the principle. Of course, in the software, we are doing automatically, but no row operation. So, you are doing complete the process like a reduced row echelon form. But this illustrates what's the principle behind this. So now, you, for example, you take the first pivot, que is this, and you create 0 below this pivot, and so on. I don't finish. No, we are doing only 3 row operation. And this answer is C, C option in the paper. Look, that one. Any question, guy? Super clear.
Yes,
Wow.
it's clear.
Okay. You expect in the test one question similar to this. Let's practice one more. Case higher dimension, however, is only two operations, no complicated. So we have a big matrix now in the question number 22. As a matrix is 1, 1, negative 1, 1, 3, 0, negative 5, 1, negative 2, 0, 2, 0, negative 3, negative 4, and 3, and negative 5, 1, 0, 5, negative 4. This is the given matrix. Okay, by the way, guys, this matrix contains 4 rows and 5 columns. Row 1, row 2, row 3, and row 4. Okay, it's important, no? Because we are doing row operations. And the row operation is the first one is -3 as a factor, multiplied by each element in the row 1 plus row 3, and store this information in the row 3. You copy -3, -3, -3, -3, and -3 5 times. Why 5 times? Because we have 5 columns, no? Multiplied by the corresponding element in the row 1, que es 1, 0, no, 0 no, 1, 1, off, 1, 1, negative 1, 1, and 3, and 3. And adding the corresponding element in the row 3. And the row 3 is 2. 2? No, 2 no. It's 2. It's 2, yeah. It's 2, 0, negative 3, negative 4, and 3. Okay, negative 3 plus 2 is negative 1. And negative 3 plus 0 is negative 3. And positive 3, because negative 3 times negative 1 is positive 3. Plus minus 3 is 0. And this is negative 3, and negative 4 is negative 7. And finally, is negative 9. Negative 9. Negative 9 is 9. Let me see, it's 3, no? Yeah, it's negative 9. Plus 3 is negative 6. Super. So after this transformation, my matrix is changing like that. Look, it's easy to copy because the only row that changes is the row 3. The rest stays the same. 1, 1, negative 1, 1, 3, 0, negative 5, 1, negative 2, 0. Now is the moment to change. Negative 1, negative 3, 0, negative 7, and negative 6. And this stays the same. The row 4. Negative 5, 1, 0, 5, and negative 4. Okay. This is the same, but this is the only escalator below, no? Because we have 4 rows. Because the final is the row operation 5 times row 1 plus row 4. Row 4, 4, 4, 4. and this you put in the new row 4. Entonces 5, 5, 5, 5, and 5, 5, 5. Multiplication by the same number, 1, 1, negative 1, 1, and 3. This is a coincidence because the manipulation is in row 1, no? Plus row 4. Okay, is negative 5, 1, 0, 5, and negative 4. This is 0, it's obvious, no? This is 6, no? Yeah. This is negative 5. This is 10. And this is 15 minus 4, 11, no? 11. Okay, so after this transformation, my matrix is, now I change the row 4, no? Okay, the row 4 is now 0, 6, negative 5, 10, and remember the bar, separate the augmented matrix, 11. And the rest I copy exactly the same, 1, 1, negative 1, 1, 3, 0, negative 5, 1, negative 2, 0, negative 1, negative 3, 0, negative 7, negative 6. Done. It's the option C again. So are you clear in this kind of question? No problem? That one. Are you clear?
Yes, it's clear.
Okay. Let's move on then to next question. Next question is about solutions. Solution of the system using matrix, using the reduced row echelon. But this is a long process. As you see, to avoid the long process, of course, we are doing using the software, no? The famous GeoGebra software. Look, 23 problem. Okay, now I skip the part because it's easy to write the matrix, no? Okay. Okay, I don't need to copy again the system because I have here in the PDF document, no? Entonces, I copy the matrix, the augmented matrix associated with the system, no? Que es negative 2, negative 1, negative 6, wow, too many negative, negative 77, negative 7, 0, because the y variable is missing in the second equation, 3, and negative 29. 0, the x is missing in the last equation, 9, 1, and 72. This is my matrix. Okay, by the way, that matrix is the order or dimension is 3 by 4. 3 row, 4 column. And now you apply reduce the row echelon form. And let's do this in GeoGebra. I want to show you again in detail. It's important that you practice by yourself this. Let me see. Do you see GeoGebra? Yes or no?
Yes.
Okay. So in any place, remember to working specifically in this kind of problem in GeoGebra. When you open GeoGebra, okay, you don't need to download anything, and you don't need to create an account if you want. If you want, you create it. It's okay. You click here and you select algebra, CAS, and spreadsheet. A spreadsheet working like a matrix editor. When you type in the matrix, -2, -1, negative something, -6, and -77. The second equation, we have -7, 0, 3, and -29. Now enter. Oof. Click here. And the last equation we have 0, 9, 1, and 72. Positive. Okay, ready. This is the most complicated part, typing that number. Well, not complicated, alone. You select everything and you create matrix. And automatically you see here in algebra the matrix. And you see the name is software associated with this. You can change or not, it's up to you. And in CAS you put reducer row echelon 4. Okay, of the matrix. You select the second option. And what is the name of the matrix? A1. Press enter, boom, and this is the answer. Okay, so the most important is the interpretation. That part is too long, so you are doing by hand. I know that. However, I evaluate this in the other question. Can you perform 1, 2, or 3 row operation, but not too much. Now, here, interpretation. So I come back to the whiteboard. In the whiteboard, I finish to explain that part. You see my whiteboard? Do you see my whiteboard?
Yes.
Yes. Okay, super. Now, let me see. Okay, the answer then is 1, 0, 0, 0, 1, 0, 0, 0, 1. And the software you don't see this vertical line, but I put it here to separate, to understand much better who is the right hand side number, no? This is obvious. It's obvious. This is a typical format in which you see the identity matrix. Look here. This is identity matrix dimension 3. Now it's clear. So you translate row by row like equation. Okay, x is equal. No. X is equal 8. Y is equal 7. And Z is equal 9. It's a typical example in which you have unique solution, only one. You see the identity matrix, no extra column, que corresponde to the extra column of the free variable. You understand very well this or not? Honestly, come on. Come on, I need feedback. Do you follow me? This is clear. Come on, guys.
Yes, it's clear.
Everyone is agree with her?
Yes, clear.
Okay, super. Okay, so let's move on to the example 24. Example 24 is similar. I want to copy the matrix directly. This is 8. This is -7. This is 3. This is 22. This is -40. This is 35. This is -15. This is 610. This is 16. -14. And 6. And -244. And we're doing exactly the same. Repetition the same. You put in the GeoGebra and put reduce row echelon 4. Do you want, can I repeat the process? So I go to GeoGebra or I put the answer directly? What do you think? In order to save time, no? So you understand very well the part of the GeoGebra? Guy, help me.
Yes.
What mean yes? What mean yes? More specific. Do you want I go to GeoGebra and do it from scratch, or I copy the answer because I did before, no? Come on, guys.
Copy the answer.
Copy the answer.
I already showed it on
Okay, very short. Okay, very well. Okay, so the answer is 1 negative 7 over 8 is a fraction. Okay, no problem. 3 over 8. And negative 61 over 9. And amazing happened que the second row is 0, 0, 0, and the third row is 0, 0, 0. That's it. Interpretation this, que is the most important. Elimination process discover que this equation and this equation are completely dependent of the first. And you can delete that. Okay? And that's obvious because somehow you multiply by -5. Suppose you multiply by -5, the equation 1. At the beginning, you don't see it clear. But if you multiply by -5, 8 times -5 is -40, -5 times -7 is 35. Okay. I don't see, but now elimination process see the idea for me. No? And the second equation multiply by 2. Okay. Now, you try to find, similar to this, the identity matrix. But in this case, the only identity matrix I can see is this. It's identity matrix dimension 1. And the rest is a free variable. So we have 2 free variables, actually. So X is the variable that is not free. In this case, X, Y, and Z. We have no extra F block que represent the free variable F block, and Y and Z is free. Entonces we have infinity many solution. It's obvious, right? Infinity many solution. Now the only I know that Y and Z are free variable and X no. X depending of the Y and Z. So the equation is X, 1X minus 7 over 8 Y plus 3 over 8 Z is equal minus 61 over 9. So you solve for X as a function of Y and Z that are free. Entonces, minus 61 over 9 plus 7 over 8 Y minus 3 over 8 Z. Entonces we are ready to write the solution. The solution, they are, remember, I explained 2 different ways. I want to repeat again this idea. Look, one way, a little bit more formal, is the solution set SS is the X, Y, Z such that X is equal, I copy this expression again, 61 over 9 plus 7 over 8Y minus 3 over 8Z, comma, and Y, comma, Z are all real number. Or not all, any real number. In other words, these variables are free. These represent, so this object, a solution object, represent a plane because we have 2 free variables and 2 free variable is a plane. No? Plane, this is not important in this. It's a plane. I need to know it's a plane. Plane in 3D context. Okay, and space. Another possibility to write this is you copy the expression minus 61 over 9 plus 7 over 8y minus 3 over 8z, and you write this in the x component. In the y component you put y and z. End the story. And the important thing is that you interpret this. You have two free variables. It's because the solution object represents a plane. See, we have one represent a line. See, we have no free variable like in this example, the previous example. So we have a point, and the point is 8,7,9. Represent a point where in 3D context. Make sense?
Yes, it makes sense.
Okay, entonces to do fast, we skip the GeoGebra part. You have to practice by yourself, no? 25 and 26 is similar. A similar problem in which you apply reduce row echelon. I want to erase that part. Boom. Okay, now what is the next? Well, the next is 25. In 25, the matrix is I copy directly the matrix, guys. 25, the matrix is okay. 1, -1, 3, -2, 2, 0, 1, 1, 1, 5, 1, and 26. I suppose in that part you have no problem. Eh? How you translate the language of the system of equations to the matrix, no? It's obvious. You have three equations. So you have three equations. Each equation represents each row in the matrix, and we have three variables. This is the column of the x, the column of the y, the column of the z, and this is the right hand side. Normally I separate in the paper by the line. When you perform the famous algorithm reduce row echelon form, you get that. You get that. 1, 0, 0, 0. 0, 1, 0, 5. 0, 0, 1, 1. Again, one more time, I can see the famous identity matrix. Dimension 3 variable. And we have no extra block. Therefore, we have no free variable. Therefore, we have unique solution. X, Y, Z. Es obvio que we have solution as a point. X equals 0, Y is equal 5, and Z is equal 1. Boom, easy. It's unbelievable how you can solve it in the real life. Suppose you have in the engineer problem, you have a system, nobody can solve it by hand because it's not too hard, but it's super tedious and everyone making mistakes. You say, what is the solution? You set out the matrix, you put in the software the matrix. This is the most not complicated. Complicated is not the adjective. It's long process, and everyone making mistake, even typing the number. When you have, for example, 20 equation and 20 unknown, it's tedious. Okay, so now let's move in. This is 25 equation. The option is 051. 051 is B, no? Es B. Es B. Okay, now 26. 26 again. is a system. Be careful, we have some variable missing. In this case, we have 4 variables, X, Y, Z, and W, and 3 equations. Entonces, when you see that we have more variables than equation, automatically you understand that it's impossible to have a unique solution, and you have infinity many solutions. I don't know si es a line, I don't know si es a plane, depending the amount of free variable, but definitely no, because remember the formula. The formula is the number of variable minus number of equation is equal to the degree of freedom. Number of variable is 4 because we have X, Y, Z, and W, no? And number of equation is given 3, only 3. And 4 minus 3 is 1. Okay, this is at least. That is under the supposition that the equations are totally independent. Because the number of the equation independent. See, these equations are dependent, entonces it's more complicated. However, no, I suppose que es independent, entonces degree of freedom is 1. That means that we have infinity many solutions, maybe at least as a line. Well, so you detecting in the elimination process that one equation is dependent, so you cancel out, so actually degree of freedom maybe is 2. But I don't know. I try. Do you understand very well this idea? This conceptual idea, no? Okay. So now I copy the matrix. The matrix is 5, 1, 0, 0, 1. 2, negative 1, 1, negative 1, and 3. 0, 0, 1, 1, and 7. And one more time, you apply the algorithm, reduce the row echelon. Okay, I skip the GeoGebra part, no problema. Y I get the answer. I need to interpretation this. 1, 0, 0, negative 2 over 7, negative 3 over 7. 0, 1, 0, 10 over 7, and 22 over 7. And the last equation is 0, 0, 1, 1, and 7. Okay, perfect. So now analyze that. I can see clear the identity matrix. That one. Identity matrix dimension 3. Exactly the same of this example. Look. Exactly the same. However, we have 4 variables. This is X, this is Y, this is Z. Therefore, we have extra block. Que es the free variable. This is the free variable. F. Que I declaré like a W, no? This is totally conventional. We have one free and you declare it either way. Pero it's obvious, I take advantage of the format. Entonces you put this as a function of W, no? Entonces it's super easy. You take equation by equation. For example, X alone is equal minus 3 over 7 plus 2 over 7 W, no? Because I write that, however, this is minus, I move to the other side like a positive, no? And Y is 22 over 7 minus 10 over 7W. And C is 7 minus W. Boom. Entonces now I know that my solution is living in the 4-dimension context. Okay, four-dimensional context is x, y, z, w, ¿no? Ajá. Entonces, en x, you replace by this. So es -3/7 plus 2/7 w. This is x component. Y component is 22/7 minus 10/7 w. And z is 7 minus w, and w is w, que es the only free variable. That means que our solution set is a line because we have only one free variable. It's a line, it's a hyperline. Because this line is, I don't know what is the shape of this line, because living in the four-dimension context, four-dimension, que es impossible imagination geometrically, right? It's the Einstein four-dimension space. Entonces now the solution is B, no? Let's see here. Solution is B. Any question, guys? Do you understand very well this complicated part or no? Everyone understand very well this complicated part?
Yes, clear.
Okay, nice class. Okay, let me erase everything. Let's move now to determinant. Determinant is another approach of the solution of the system. I don't know why some people, okay, you have to page more, prefer doing by determinant. After when you finish, you let me know what way you prefer. So we study three different approaches to solve the system of equations. Okay, so let's do something. I want to do 27, 28, and 29. I do 27 by hand and show you how you solve it in the GeoGebra. Okay. And after we skip the GeoGebra part, no? Okay. The determinant that I need to compute is, and the 27th question is 1, 1, -2, -2, 4, -1, -3, 5, 5. Okay, remember, the answer of this is a number. But this is the idea for the determinant. Determinant associate 1 square matrix 3 by 3. But actually it's no matrix, it's a determinant with the one number, according to the formula. So what is the formula? Well, the formula is the cofactor formula. Cofactor formula. And the cofactor formula is very, very flexible because you can expand the determinant using any row or any column. Frequently, the people prefer expand using the row 1. So we navigate 1, 1, and -2. And you determine the cofactor associated with that. It's, for example, 1 first. You copy 1. And si es 20, you copy 20. And the cofactor is a new determinant que es formed when you delete the row 1 and column 1. Entonces 4, -1, 5, 5. Do you see that? The confusing part is when you select the next number inside the row, okay, you make a decision to expand. This is -1 because the sign is alternating plus, minus, plus, minus, plus, minus, plus, minus. And the cofactor, well, the cofactor includes the sign. One cofactor is positive, another cofactor is negative, and so on. So now is -2, -1, -3, and +5. Where come from that number? Is when you delete mentally this row and this column, stay that number, right? And finally, positive, but actually the number is -2. Entonces -2 time the cofactor is determinant form, in this case -2, 4, -3, and 5. Do you see that? This is the algorithm, okay? You have a big dimension. Suppose you have one determinant 4 by 4. So you apply the cofactor formula and you convert 4 3 by 3. It's too long process. In this case, 3 by 3, and you determine by 3 determinant 2 by 2. And 2 by 2 is relatively easy. Computer. Is when 1 is invisible factor, you multiply is 20. So 4 times 5 is 20. And remember, when you apply in the principal or main diagonal, the sign is positive. And when you apply the secondary diagonal, is extra negative, no? So actually, we have 20 positive and positive 5. Because double negative, so that's negative together is positive. Minus, -1 is minus, and you multiply. This is -10. And we have -3 negative actually. Negative is negative. It's -3. -2, we have -10 and positive 12. Okay, this is 25. This is 13 positive because it's negative, and another negative in the front become positive. And this is 2 positive 2, and -2 is -4. So the answer is 34. 25, 13, 8, 38, plus 4, minus 4, sorry. This is plus, this is minus. The answer is 34. Do you understand the step or not? This is important. Okay, maybe it's the last time you see this. After you need to do by yourself in the test. And the test you show me the word. And using your algebra if you want to double check it. Okay. Any question? Any question? Any question? Clear or no? Answer me. I need feedback.
No questions here.
No question. Clear, right? Do you consider? Well, see, yes. I suppose that it's important to see in your algebra at least one time. Okay. 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 There you go. Okay. Do you see Georgia, right? Yes or no? Okay. I delete that. I only put the number inside this one. Let me type it. 1 tap. 1 tap. -2. Enter. -2. Tap. 4 tap. -1. Enter. You press enter, change the line. When you press tab, you move it to the next cell. -3, exactly what the cell, no? -3. 5, 5. 5 and 5. Okay, this is a square matrix, 3 by 3, 9 elements. You select, create a matrix, no problema. Boom, it's a matrix. More en CAS, que the CAS is the computer assistant software, so it's the arithmetic for the matrix or another thing. You type in determinant, look at that, determinant of what? Of the specific matrix. What's the name of this matrix? Anyway. Present 34, double check, and do it well. Any question? Any question? Any question? No?
No questions.
No questions.
Mm-hmm. Or I explain very well, or you are super good students, no? Or both, no?
That's a lot, but you're explaining it really good.
Okay, this is the 27 question. 28 and 29 we are doing fast because, well, first of all, see, I do by hand. Look at by hand is easy because I take advantage the fact que this determinant is 300. Wow, entonces si es I navigate for the first row, we have only one cofactor. Sorry, do you see the whiteboard or no?
We still see the algebra.
Okay. Yeah, I forgot to switch it. Now it's okay?
Yes.
So the thing I try to explain is that I take advantage the zero that we have here. When you navigate for that row, it's 3 times something. And the determinant is formed by 6, 4, 9, and 8. And that's it. Because the rest is plus 0 times another, plus 0 times another. Entonces it's 3. And you multiply, remember, this guy times this guy, and no change the sign. And you multiply this guy times this guy, and extra -1. Entonces actually is 48 minus 36, que es 9 times 4. Entonces this is 12, 3 times 12, que the answer is 36. Ese es the answer, que corresponde with the option C. Super clear? And 29 is very, very interesting because you don't need to do anything. 1, 2, 3, 2, 5, 5, and 1, 2, 3. You realize that this row is identical. I know one property can say that when the 2 rows or 2 columns are equal, the determinant is 0. Okay? Without do anything. And you see, you apply the property number 3. They say that when the 2 rows or 2 columns are the same, or not necessarily the same, they are proportionally, it's also 0. Suppose that the 1, 2, 3, and this is 2, 4, 6. It's also 0. Or negative, it's also 0. Because you multiply the row 1 times 2 or times -2. And the answer doesn't change, it's 0. Unbelievable. Do you see that or no? You see that or no?
Yes.
Okay. Now let's move on to the one long problem. Okay, I promise you see one of these in the test. It's about Kramer rule. Kramer rule is the application of the solution of the system of equation using determinant. Okay, the system is, look, let me show you from scratch. And also we finish in the algebra to verify, double check. Suppose this system. Okay, this is my first equation, 52. My second equation is minus 6x plus 3y minus az equal -42. Equation 2. And this last equation is 2x minus 6y equal -40. Okay, no problem. but they want using Kramer rule. Okay, it's important. One question in the test using Kramer rule. So you solving this question using another way, using reduced row echelon, because I lie, you have no credit because the command is clear, Kramer rule. Okay, because I want you show me you know Kramer rule. So remember, Kramer rule is easy. Or the organization is relatively easy. You compute capital D. Que determinant, always determinant is formed by square matrix. Okay, it's formed by the coefficients in front of this, the variable 5, 0, 9, 0 because y is missing in the first equation. Minus 6, 3, minus 8. 2, minus 6, and 0. Now we can compute by hand, but no, hello. It's too long. It's not hard, but it's consuming time. This is a problem, no? It's not complicated, it's long process. You set out dx and dy and dz. Okay. Okay. According to the Kramer rule organization, is you replace. You have three columns. No? This is column X, column Y, column Z. You replace the column X for the right-hand side number. Now 52, negative 42, and negative 14. And the rest stays the same. Likewise, now, but in this case, you replace by the column of the X. Entonces, the column of the X stays the same. The column of the Y, because it's dy, replaced by the right-hand side number. And the column of the Z, no, stay the same. Now this Z, let me try to do much better this line. 5, negative 6, 2, 0, 3, negative 6, and now it's 52, minus 42, and negative 40. Do you see clear the organization of the Kramer rule? So I like, don't do by hand. No, you go to the GeoGebra and you find the number. I did that, and the answer is 30, 150, 120, and 90. Okay, now the rest. Okay, what you are doing is find the X value, get the solution, Y value, get the solution, and Z value, get the solution. And this is super easy. You divide dx divided by d, dy divided by d, and dc divided by d. dy is 150 divided by 30 is 5. dy is 120 divided by 30 is 4. And dc is 90 divided by 30 is 3. And the solution for the our problem is 5, 4, 2. Unique solution. Okay. Do you want to do for you in GeoGebra or no? You consider it's important or no?
Yes, it's important.
It's important. Okay, super. Let me switch into GeoGebra. Do you see that?
Yes.
Okay. You type in one by one. The first is D. D is 5. 0, 9. Enter. -6, and positive 3, -8. You let me know if I make a mistake, guys. I am human. Okay, now to -6 and 0. My first. Here I don't know why. Copy the right hand side, get 52. -42. And -40. Okay, so I can copy that, copy, and paste in any place. Boom, 3 times. This is for D, the X, the Y, and the Z. And you replace. Select this, copy, and you replace here for the paste. Excellent. Paste here. Paste, and paste here. Do you see que es easy? The matrix editor. Entonces yo declaré one by one matrix D. I want to change the name. Matrix. I change the name to guide me better. Rename D. D. Okay. And you want to compute the determinant, or we continue to create the matrix? Create matrix. And this is TX, remember. Doesn't matter if it's capital, I don't care. Okay, now dy. Rename, you click and select rename, dy. Okay. And this. You see it's a long process, but do it by hand is long. No? And now I just think I check and say I do well, no? Matrix. Okay, and rename DZ. Okay. And you compute a determinant. Determinant. In the arrow, you select this option, que es matrix D. Capital D. Is 30. Exactly I did before. Determinant. Determinant dx. Determinant dy. 120. And determinant. Make a mistake. Determinant dz. And the division, no, division you are doing by hand in your paper. Super clear? When you are doing this in your test, you can watch the video of this video, no? To see again, so you forgot one step. Any question, guys? Super or no?
Good.
Good. I want to hear that. Good. Okay. Entonces, Kramer rule, no problema, ¿no? Okay. Let me erase everything. One question like that in the test. A mandatory doing in that way. No echelon. The echelon is easy because you type only one matrix. Okay. For Kramer is important. Okay, now in the question 31st and 32nd, we have a application of the property, no? So one determinant is given, but not complicated, it's not easy. Look, one determinant is given, and we cannot use in GeoGebra because on no software, because it's a letter. Si es a number, yes. Pero si es a letter, no. Entonces, this is given que 1, -3, and 1. And it's given que the value is 38. I need to compute one similar, pero no. Es X, Y, UB, and 1 and -3. You see que the column 1 and the column 2 of this determinant is identical. Wow, the column 3, no. The column 3 is Z minus X. W minus U and -2. I need to compute this using the property. Remember, we have different property. You don't need to know my memory. However, the most important property is, or the most frequently property you apply is when you perform row operation or column operation, because in determinant we can use in column operation. Well, you can, the value of this determinant stays the same value is given in 38, no? But in this case, I can see, look, oh, for me it would be fantastic. Okay, magically, I delete this, and this become like a 1. No? Entonces, one row column operation is column 1 plus column 3 equal capital column 3. Okay, entonces es basically. Ay, sorry. Sorry. I always forgot. Same to you, you will remind me. A ver, where is the whiteboard? Hello. Okay. You. This is a complicated, not complicated, you know, is frequently when I grade the test, the student don't understand very well that. Okay, I try to explain the question 31. And 31 is given one determinant. I need to compute another determinant that is similar to the given. However, you see guess, for example, the column 1 and the column 2 is identical. However, the column 3 no, it's different, for example. Entonces it would be fantastic you manipulate not the original, you manipulate the new one using column or row operation. In this case, I suppose it's column operation much better, right? In order to find the value of this. So I can see, for example, column 1 plus column 3, suppose que I manipulate column 1 plus column 3 of this and stores the new function in column 3. So when column 1 and column 3 participate in the game, however, the only column que change is column 3. Entonces X, U1, Y, B, and -3 stay the same. This is column 1 and column 2, and new column 3, guess this, is addition. So you adding X plus C minus X. Es obvio que this X is cancelled and stays C. Likewise, in the column 2 is U plus W minus U is se cancel out the U part, que es the part I want to eliminate, and it's W. And here is 1 minus 2 es, a ver, es -2, ¿no? ¿Es -2? No. 1 minus 2 is -1. I suppose that this is -1, guys. So you change this in the test, I suppose that you have no problem. Ah, es negative 2. A ver, es negative 2. Es negative 2. A ver, I copied wrong maybe. Wait a second. Okay. Es negative 1 ya. Es negative 1. Es negative 1. Entonces, es 1 plus negative 2. Es obvio que es negative 1. Entonces, now, in this moment, this is the good thing. Que this determinant is identical to the original and the answer is 38. Okay. Entonces es negative 1. Yeah, perfect. I don't know why I copied wrong in my paper. Es negative 1. It's negative 1 because 1 plus negative 2 is negative 1. It's obvious, right? Good. Any question? Do you understand this problem? This is easy. However, the student, I don't understand. Left this question in the test in black. Not do anything. And 32 is similar. Any question, guys? Do you follow me? Column operation. I did column operation. Column operation. Okay. Boom. Let's do it one more. Well. This is 32. Is one determinant is given. X, Y, Z. UBW. 1, negative 1, and negative 3. The answer is 146. Yeah, I need to compute another more complicated, but it's similar to the original. It's x plus 3, y minus 3, c minus 9, 3u minus 1, 3b plus 1, and 3w plus 3. And 1, negative 1, and negative 3. At least the last row is identical, no? You need to perform two operations. In this case, row operation. No? Remember, this is row 1, this is row 2, and row 3. So you need to use imagination. For me, it would be fantastic. See, you, for example, eliminate that 3, and this 9. So one way to do this is perform this row operation. Row, negative 3, row 3, plus row 1, and store this information in the row 1. Okay, so when you are doing this action, I can see, easy to understand. Okay, when you multiplication by 3, each element in this, adding with this, it's obvious que negative 3 and positive 3 is cancelled. It's obvious que positive 3, because negative 3 times negative 1 is positive 3, and negative 3 is cancelled, and likewise 9 is cancelled. So it's x, y, z, 3u minus 1, 3b plus 1, 3w plus 3. And I stay the famous 1, negative 1, and negative 3. Do you see the transformation? Do you see? Do you see?
Yes.
I propose you another transformation, but this is easier. This is row 2 plus row 3 would equal row 2. So in this case, you adding this row. So the first stays the same, doesn't change. But the second, well, you adding this, cancel out negative 1, positive 1. positive 1 and negative 1, and positive 3 and negative 3, and stay only 3U, 3B, and 3W, and 1, negative 1, and negative 3. Do you see that? Do you see that?
Yes. Yes.
Now we apply another property que is no row operation. No. The row operation, when you perform row operation on the determinant, the answer stays the same. However, if you multiply any row or any column by the number, the new determinant is multiplied also by the same number, right? And you see that 3 is a common factor, and you factor out. Do you understand this operation? Factor out only in one. So it's completely different to the matrix. Matrix, when you multiply the matrix times a number, you multiply everything. But determinant, no. You multiply one column or one row by the one specific number, and you multiply the value of the determinant with this. And you see that this is identical to this. And you replace by that number. So 3 times 146, and the answer is 438. Que es the option. Do you understand this or no? Okay, unfortunately, we cannot use it. In this case, software. It's by hand. Okay. Next question is the multiplication of the matrix. Operation on the matrices. Do you understand this? The application for the property of the determinant or no? Yes or no? Tell me. Complicated or easy? Guy, I need your answer.
Yes, we understand.
Okay. Okay, entonces now multiplication of the matrix. You multiply two matrices, and the question number 33. The most important thing you need to understand is when you multiply two matrices, sometimes it's possible, sometimes it's impossible, depending on the dimension, matching or not. Suppose this matrix multiplication by this matrix, que is -3, 8, -6, -3, 7, -2, -2, -3, and -2. Okay. Now the most important is analyze dimension. Dimension of that matrix is 3 by 2. Because we have, no, 2 by 3, sorry. 2 by 3. 2 by 3. Because we have 2 rows, look, and 3 columns. And this no, this is totally square, 3 rows, 3 columns. And remember, this number and this number must be the same. Si es the same, it's possible doing the multiplication. Si es different, no, it's impossible. Okay, now you put it here. I expect one matrix is 2 by 3. This 2 is that 2, and this 3 is that 3. So in total, we expect 6 numbers. 1, 2, 3, 4, 5, and 6. So I highly recommend that you are doing not by hand. It's crazy because you multiply, for example, this times this, and you get that number. This times this, and you get that number. This again, row 1 times column 3, and you get that number. Now Let me using another color, maybe purple color, okay, highlight. You multiply this times this again, and you get this number. And this times this, and you get this number. And the row 2 and the column 3, and you get the number. Okay? Do you want to do in GeoGebra or no? Or you can do by yourself? Answer me.
Yeah.
Okay. Okay, no problem. Let me switch. You see now?
Yes.
I type the two matrices separately. In any place. This is matrix editor. Super easy. You put 3, 6, -8. -9. 4 and -2. Boom. I did that. The first one. The second. -3. 8. -6. -3 again. 7. -2. -2. Repetition. -3. -2. Okay. When I finish the typing, you define, you create your own matrix one by one. Exactly the same we are doing in other problems. Not in CAS, que es the part que allow me multiplication, you multiply and matrix 1 times matrix 2. And the ordering is extremely important. So you are doing Bauer community, you believe que es no, it's completely different or impossible. Dependency matching on all the dimensions. So you type it N1 time, que time is obvious in the keyboard is shift and the key 8. Enter. Bam, and this is the answer. The answer is -11, 90, -14, 19, -38, and 50. Get the option D in our handout. Clear?
Yes.
Let me now switch into whiteboard. Okay, entonces in this problem, you don't need to do by hand, only using GeoGebra, okay? Next example, you see, let me try. Oh, no, the next page. Okay, there you go. This is the last page. You see it's impossible doing the multiplication. So it's totally not defined. Because in the first matrix, you have 3 rows, 3 rows and 2 columns, multiplied by another matrix is exactly the same, 3 times 2. That number don't matching. Entonces the answer is impossible. Good. Suppose que you don't know, and you put in GeoGebra, and when you try to do multiplication, GeoGebra say impossible because mismatching connection something. Add the matches for the GeoGebra. Good. Let's do it one or two problem of the inverse matrix. Okay, let's do it by hand, and after why not, let's do it by GeoGebra. Okay. Now 35. Let's compute the inverse matrix of this. Look. Inverse matrix of the matrix capital A is 4, -1, 5, 1. Let's do it by hand because it's easy. First of all, you compute the determinant of this. Determinant 4, -1, 5, 1 is, remember, multiplication this and this, plus and multiplication this and this, minus. It's obvious is 4 times 1 is 4, plus, double minus plus 5, is 9. Now, the algorithm to find the inverse in 2 by 2, of course, is you interchange 4 and 1, you put 1 here and 4 here, and divide it by 9, get the determinant. And this stays the same, but you change the sign. This is 1, and this is -5, and divided by 9. Do you understand this, or I explain much better, more clear?
Can you repeat it?
Absolutely, absolutely. Suppose the formula is you have a matrix, and the number is A, B, C, D. This is a matrix capital A. To find the inverse matrix, you compute the determinant first, que es A, D, C, B, is A times D minus B times C. You interchange A and D. You put here D and you put here A. Interchange this guy. This is the rule. This is the formula. And divided by let me call this D. And here no interchange. Stay in the same place, but you change the sign. Minus B over D and minus C over D. Now it's clear?
Yes.
Okay. Our previous example, the determinant was 9. You divide any element by 9. Interchange 4 and 1 and change the sign -1 and +5. And that's it. Super. Do you want to get double checking and GeoGebra this idea or no? Yes, no? Yes, okay. I suppose you see GeoGebra, right?
Yes.
Okay, you type in that. Okay, 4, 1, 5, and no enter. Tap. 1. This is my matrix. I select, I create the matrix as always. Boom, I have that. And the case you put invert. This is a notation, guys. Invert, like that. Invert what? Invert matrices. Invert function, no, invert matrix. What matrix? M1. Boom. Yeah. No, something wrong. Let me see. Invert matrix. It's supposed to be here. Because I make a mistake here. Look, I make a mistake. Yeah, it's good. It's no 4151, it's -1 here. But don't worry, -1, I put -1, bang, I enter, get it inside, and you see the answer here. You see or no? Or let me see if I can delete that part. Delete row 2. Okay. Do you see or no? Yes or no?
Yes. Yes.
Okay. To double checking see everything is okay or no, if you multiply matrix 1 times invert matrix 1, invert matrix 1, the answer should be no, must be the identity matrix. You and in the order. Do you see or no? Okay, example 36 is repetition, the same stupid thing I don't want to do again, no? I move on to the interesting part, get the last two examples, pero si we are solving only one, it's okay. And don't, because it's the same thing. I want to solving and the whiteboard, and also I double check it in GeoGebra. I come back to the whiteboard. Okay, whiteboard. Do you see whiteboard?
Yes. Yes.
Okay. So I want to skip 36 because it's the same thing, right? You try to practice by yourself. We move on to 37. 37 is solving the system, but using the formula for the inverse matrix. So it's another way to solve the system of equation using matrix, but it's using the inverse matrix. So you have the capital A matrix. Okay, the matrix formed by the number in front, the coefficients in the variable. Okay, this. You have the matrix B. Okay, by the way, okay, this is 3 by 3. Must be square. Is 4, -5, and -6. You need to find the x, y, z. So the formula for the inverse matrix is given, and you can check it. This is complicated to do by hand. There are no rules. So using GeoGebra, you put invert matrix A, and you get this answer. -2. Let's check it. 4, -1, 3, -5, 2. This is given in the problem, no? However, you check it to verify, double check it. And finally, the famous vector que corresponde with the verb x, y, and z is multiplication A inverse times B. It's the formula, guys. And the answer is, I want to show you now, -22, 25 positive, and -8. Therefore, the super fantastic conclusion is x is equal -22, y is equal positive 25, and z is -8. Okay, and let's do it now in GeoGebra. This job. Because we are doing in GeoGebra or another software when it's too long process, no? And when you're increasing the dimension of the system, suppose que 4x4 it's impossible to do it by hand. It's impossible. Well, it's possible, but maybe you spend 2 weeks doing that, and you make mistake in one stupid arithmetic thing, and you never get the answer. So nobody in the real life using, when you solve this technique, using software, it's software, right? Do you understand the main idea? Let's move into GeoGebra now. And this is the last problem. Okay. Erase. And you copy A matrix here. Why not? Okay, 1, 2, 3. 1, 2, 3. 1, 1, 1. Oh no, enter much better. -1.
Professor, see our break.
Oh, sorry. You don't see, you see whiteboard now, no?
We see
What do you say?
like a screen.
Uh-huh. GeoGebra Classic. I'm switching. I don't know if you see or no. You see or no? You see or no?
No.
Everyone say no?
No.
No. Okay. Okay. Stop sharing. And now sharing only GeoGebra. Now?
Yes.
Okay. Sometimes happen. I need to stop sharing. Okay, this is 1 of. This is 1. And this is 2. This is my matrix A. And my matrix B is -9. Enter. -12. Enter. Oh, I screw up everything. Carajo. This is 1. Okay. -12. And 8. Negative. Okay. I create both matrices, A and B. I rename. Put capital A. And this is capital B. Create matrix. Okay, capital B. Okay, capital B. Ready. Ajá, entonces, inverse matrix. Okay, invert. Invert. Invert 8. Exactly the same. But this is given. Now, the most important is the multiplication. The inverse matrix is this. If I type in invert matrix A, it's important the order, guy. Outside time B. Push. What the hell? Time, shift 8 B capital. Enter. Boom. 11, -49, and +26 is the answer. Wow, fantastic. So I do my job. Now it's moment to, okay, you need to do your job, right? Remember, I collect the test, written test, this Thursday, April 14. And I will check in, of course, I will check in Friday, no Thursday. Thursday at midnight is the time, it's the due date, no? To turn into me the test. It's clear the idea, it's confusing the idea. Clear, confusing, clear, confusing. Come on, guys. Come on. It's clear, okay. Okay, you see my face now?
Yes.
Okay. Entonces, okay, we start Thursday, the last chapter. Okay, it's easy, relatively easy. This is a complicated chapter, eh? What do you think? What is the complicated? Number 1, number 2, number 3, number 4 chapter so far? In your opinion, I need to hear opinion. This chapter, okay, Carlos Lopez say, I believe in Carlos because Carlos is a smart guy. Okay, guys, good luck. Bye-bye.